I am Michael Bush. I work with Jean-Luc Margot's group here in Earth and Space Sciences, primarily on near-Earth asteroid observations. So near-Earth asteroids are small objects that cross the orbit of the Earth. The main asteroid belts between the orbits of between the orbits of Mars and Jupiter. And the near-Earth asteroids have been kicked in from there and now cross the orbit of the Earth. There's about 1,000 of them bigger than 1 kilometer, and many more smaller objects. We try to understand their shapes and spins and what they're made of and how they came to be in that situation. The most immediate interest here is the asteroid impact hazard. Occasionally one of these things will hit the Earth. The most famous example is the dinosaur killer, which impacted in Chicxulub in Mexico about 65 million years ago. We'd like to know if that's going to happen in the future. There's a lot more broader science here as well. You have an object shaped like this. These things are so small that they are not round. The real one that this is a model of is called Toutatis. It's about 6 kilometers long. But it's got some really complicated shape. And we think what happened was there used to be 2 objects that were in orbit around each other, and they recombined very gently, and now resting one on top of the other. And this whole process is acting in a very unusual environment. It's microgravity, you're out in space, and you end up being dominated by the effects of sunlight on the surfaces of the objects, pushing their orbits around, spinning them up. They fly apart or they recombine. It's a very strange, complicated, weird process going on here. If we want to understand where these things are going, we have to understand their shapes and spins and physical properties. And that also tells us quite a bit about the history of the solar system, because the same processes act in the asteroid belt, just more slowly. And the structure of the asteroid belt reflects what happened when the planets were forming 4.5 billion years ago. So we have a radar transmitter, one at Arecibo in Puerto Rico, the other at the Deep Space Network site in the Mojave, run by NASA. And we transmit a signal up to the asteroid, and we bounce it off the surface. And we listen to the echo that comes back down. And we code the signal that we send up so we can resolve the object in distance from Earth. So we can tell this part of the surface is so far away, this part's 2 meters further away, or 4 meters, or 10 meters, or 4 kilometers. The best resolution we can get this way is a few meters, which is incredibly good for any form of ground-based astronomy. It's the sort of resolution you get from a spacecraft flyby. It also tells us very, very precisely where the object is in space, which lets us predict their orbits into the future very, very accurately. So there's an asteroid that flew by quite recently, first week or 2 of November, called 2005 YU55. We give the asteroids telephone numbers based on the year and the time within the year that they were discovered. So its orbit is inclined a bit relative to ours, so it actually can never hit Earth. It always passes a couple 100,000 kilometers above the North Pole. So we observed it this time as it flew by, and obtained quite a bit of good data because it was so close. It was only 85% of the distance of the Moon, about 300,000 kilometers from Earth. That let us get images with a resolution of about 4 meters. We have information how it's spinning, and actually now I'm trying to understand how its spin state changed as it flew by Earth. Because the Earth has slightly different gravity pulling on one side of the object than the other. This creates a tide which tends to spin the object up or down, depending on its shape, and how it's spinning itself as it comes in. And that tells us stuff about how material is distributed inside the asteroid. It was all quite exciting work, but you don't have to worry about YU55 hitting the Earth at any point in the next several hundred years.